Okay, hi everyone. Hopefully you can hear me now. So what we're going to start with, we're going to start by correcting the questions I left you with yesterday, right? I left you with the three questions that I've copied here at the top of the page. And really the first thing we're going to do here is correct them. And again, this is with a calculator. So you should be able to see my calculator on the screen there. Don't worry, I'll be moving this around when needs be. So, when we get to the third question, I'll move it around. And we'll see how this works, okay? So let's see, the first question that I asked you to do, if I start correcting it, we have 6 to the power of x, which equals to 10. And the approach here, as we saw, is to apply logarithms, or we often just say take logs, of both sides of this equation. Now, if I do that, I'll go ahead and say, all right, well, log of 6 raised to the power of x equals to log of 10, right? And once we've reached this stage, we're in a position to, how would I put this? We're in a position to use the third law of logarithms that we saw. And I'll copy it just once at the top of the page here. Remember, we saw that for any base b of a raised to the power of x, so any number a raised to a power of x, we can go ahead and we can state that that's equal to x times log base b of a, right? We've seen that quite a few times now. Now that's exactly what we're going to be using again to solve this, and it allows us to take the exponent, this power of x, outside of that exponent. So in doing so, this quickly turns into x times log of 6 equals to log of 10. Okay, and I didn't specify anything here, but remember from yesterday I told you our last session that when we write log without a base, it's implied that we're working in base 10. Okay, so just keep that in mind. I now divide both sides of this equation by log of 6, and that leads to x equals to log base 10 of 6, log base 10 of 10 divided by log base 10 of 6, or just log of 6. Yeah. Now, at this stage, I'm quite certain that given this is log base 10, for the top one, we don't actually have to plug it in our calculator. Hopefully you can tell me that log base 10 of 10 is just going to be equal to 1. So in fact, this first one is just equal to 1 over log of 6. So if I go ahead and actually calculate that with my calculator, so I'll do that at the top here. So let's see my calculator. I want to calculate log, so I press on the control button and the 10 to the power of x, above which we have log written, right? So if I just go control log, the base is 10, and just to show you the first result, log base 10 of 10 is of course 1, right? So that's why I wrote a 1 at the top. But now if I undo that, and if I do 1 divided by log base 10 of, 6. Okay, and if I do that, we get that number there. So the actual answer is x equals to, if I'm seeing that correctly, 1.2851. 2851. Yeah, that's the answer. Now if I move on to the second question here, we have, it gets a little bit more complicated, but all I wanted you to see here and remember is that to solve this type of equation, the key thing that you have to do is isolate the number which is being raised to the unknown power, this x here. So in this case, we need to isolate 4 to the power of x. Another way I could say that would be, I want to make 4 to the power of x the subject. So let's go ahead. I'll start by getting rid of this 1, which is being subtracted here. To do that, I add 1 to both sides. So let's see, I'll have 7 times 4 to the power of x equals to 33 plus 1. That leads us to 7 times 4 to the power of x equals to 34, right? Now that that's done, this 4 to the power of x is being multiplied by 7. So to get rid of this 7, I'm going to divide both sides by 7, right? And that leads us to 4 to the power of x equals to 34 over 7. Finally, we're going to apply logarithms. And so I'll just go ahead and say, all right, well, log of 4 to the power of x equals to log of 34 over 7, right? Now, I use the law that we have, that I wrote at the top of the page here in orange, and I can go ahead and state that x times log of 4 equals to log of 34 over 7. Finally, if I divide both sides of this equation by log of 4, that will isolate the x, and we'll be able to say that x equals to log of 34 over 7 over log of 4. And at this stage, really, this is where we stop. We're just going to use our calculator. And to calculate that, let's see, we need to do the first log, so I'll do control 10 to the power of x, so log base 10 again, of 34 divided by 7, right? I exit the logarithm like so. I now divide all of that by log base 10 of 4. There we go. Exit and enter. And if I'm reading that correctly, I'm getting x equals to, what is that? 1.14005. And that's the answer for the second one. Okay? Now for the last question, I need to move the calculator a bit. Let's see. I'll move it over here on the far left-hand side. There we go. For the last question, the method is very, very similar to the one we just solved. First thing I need to do is isolate this 2 to the power of x. And for that, I'm going to start by getting rid of this 1 that's being added to it. So I do that by subtracting 1 from each side. And in doing so, that turns into 5 times 2 to the power of x, which equals to 12 minus 1. That becomes 5 times 2 to the power of x, which equals to 11. Now, I have a 5 which is multiplying this 2 to the power of x, so I need to get rid of it. Since it's multiplying, the inverse operation is division, so I divide both sides by 5. That leads us to 2 to the power of x equals to 11 over 5. And again, I mean, here, you could actually calculate 11 over 5. You could write it as a decimal if you wish. At an IGCSE exam or at your end of year exam, I'll be honest and just say, if you're dealing with a calculator paper, just go for the minimum risk. Try and avoid the silly mistake, and use the fact that you're given access to a calculator. So I would quite literally just leave it as 11 over 5 and then apply logs. So I write log of 2 to the power of x equals to log of 11 over 5. I now use the law that we have at the top here, and I can state that x times log of 2 equals to log of 11 over 5, right? Finally, I divide both sides of this equation by this log of 2, which is multiplying the x, and that leads us to x equals to log of 11 over 5 over log of 2, right? And once more, we dive on the calculator, and if I do that, let me just check, there it is, that gives me, let's see, log base 10 of 11 divided by 5 divided by log, actually, sorry, I'll just go through the full control, there we go, log base 10 of 2. Yeah, and that's equal to 1.1375. So let me write that. That's 1.1375. Done. Okay, and that's the solution key, if you wish, or the full correction of the 3 questions I left you with yesterday. So in the last video. Now, what we're going to do now is work through a few more complicated cases, as well as see how some of this stuff can be used for things like sequences, okay? And we'll also look at some inequalities involving logarithms and powers of numbers, all right? So if I go ahead and go to the next page, and in this case I need to move the calculator again. There we go, and I'll put the calculator at the top, like so. Now looking at this, we can see here that we still just have, as such, this is an exponential equation. So we have 3 to the power of 2x equals to 12. And the only real difference for now in this one, compared to the previous equations we've seen, is that in this case, it's not just 3 to the power of x, it's actually 3 to the power of 2x, right? Don't let that bother you though. The approach is still, I want to say, identical. Okay, so the first thing we're going to do here is we'll just go right away and apply logarithms to both sides of this equation. Okay, so in doing so, I'll go ahead and say, all right, well, log of 3 raised to the power of 2x has to be equal to log, base 10 of course, of 12. Now I can take this power of 2x outside of the logarithm, and it turns into 2x times log of 3 equals to log of 12, right? Now we need to isolate this x, right? So we need to be thinking, there are several approaches here. I would just really keep it as simple as possible on a calculator paper and say that, okay, well, this 2 and this log of 3 are multiplying each other, right? So if I want, I can just say, if I were to detail it, I could go ahead and say this is the same thing as x times 2 times log of 3, and that's equal to log of 12. And I quickly see here that all I have to do to isolate the x is divide both sides of this equation by 2 times log 3. So in doing so, that quickly leads us to x equals to log of 12 over 2 times log of 3. And now at this stage, it's kind of up to you. You could just plug that straight into your calculator. And in fact, maybe it's advisable, like I said earlier on any exam, you don't want to make any silly mistake. But if you wanted to, you could also say, you could use this 2 that's in front and place it as a power on the 3, right? So again, I'm still using that same law, and I'm sorry, I'm going to write it again. That log base b of a to the power of x, which equals to x times log base b of a. We can read this from left to right and from right to left. So if I were to look at it from right to left, hopefully you can see that this 2 log of 3 can actually be written as log of 3 squared, right? And that would therefore turn into log of 12 over log of 3 squared, which is 9, okay? So again, on a calculator paper, really, you could write either this or that in your calculator. It will make no difference, okay? You'll still get the points. So may as well use this one. But now, if I go ahead and actually calculate that with my calculator, what do we get? Let's see. We'll have, I've got to type log base 10 of 12, so let's go for that. Log base 10 of 12, and that's divided by log base 10 of 9. Okay, so log base 10 of 9. That's equal to 1.13093. So if I write that, that's 1.13093. That's the answer. Now, just to highlight the fact that, or actually sort of, how would I put this? Just to sort of justify the fact that I actually prefer writing it this way before I plug it in my calculator, I'll just show you how I would have to write it in my calculator here. I just, for whatever reason, I find this to be more work than this. And here's what it would look like. So I'm plugging this expression inside my calculator. It would look like this. I go, okay, the numerator is the same, so I have log base 10 of 12, fine. Then I divide by, and when I divide by, I sort of have to write the whole thing inside a pair of parentheses now. So I open up a pair of parentheses, 2 times log base 10 of 3. Oops, sorry, 3. There we go. I exit all the parentheses and I type enter. And of course, I get the same result, right? For whatever reason, I'm sort of, I don't like having to add that extra pair of parentheses in my calculator. I don't know why. You can do it, it's not a problem. Now, looking at the second question here, the approach is still going to be very, very similar, Okay, I still just have some number raised to a power, and there's the unknown that we're after inside the power, and it's equal to a constant. Okay, so the first thing I'm going to do is get this x plus 1 outside of that power. Get it away from there. For that, I use this law again, right? And so I can go ahead and state, well, I'll just apply logarithms first. So log of 5 raised to the power of x plus 1 equals to log of 24, right? Now that that's done, I use that law and say, okay, well, I can take this exponent out. But careful, because when you do that, because there's more than one term in the exponent, we have an x plus 1. So there are two terms there, and they're being added. And if they were being subtracted, it would be the same. Because of that, you've got to write that inside a pair of parentheses when you take it out. In other words, this turns into x plus 1 inside a pair of parentheses times log of 5. And that's equal to log of 24. Okay? Now that that's done, I need to isolate this x, this x here, there we go. And for that, I'm going to divide both sides of this equation. I'll start by dividing it by log of 5, okay? And that will leave me with just this pair of parentheses here. So if I do that, I'll divide both sides by log of 5, and that leads to x plus 1 equals to log of 24 over log of 5. Now I should say, notice that here, once I divided by log of 5, I no longer need that pair of parentheses, which is why I didn't bother writing them here. Okay, hopefully that was clear. I'm nearly there. All I have to do now to isolate x is get rid of this 1. And this 1 is being added on the left-hand side, so to get rid of it, I subtract 1 from both sides. That leads to x equals to log of 24 over log of 5 minus 1. Yeah? Now that that's done, I dive on my calculator. Okay, no doubt about it. I just go for it and figure out what x has to be. So if I plug in log base 10 of, what was it? We have 24 divided by log base 10, so control, there we go, log base 10 of 5, and I take 1 away from that, minus 1, we get 0.974, 0.974, what is that? 636. Okay, so that's the answer. We have x equals to 0.974636. That's what I'm getting on my calculator. Now I should also say, by the way, at IGCSE, of course, you would never be asked to write that many decimals. Typically, you'd be asked to round to 3 significant figures. So, this first one would be 1.13. The second one would be 0.975, okay? Now, for the last question, and then I'm going to ask you to do a few. For the last question here, I need to move that calculator, don't I? So let me just move that to the side. There we go. I'll cover the first question with the calculator. We have 7 to the power of 2x minus 1, which equals to 150. All right? So, again, the approach is still the same. First thing I'm going to do is apply logs. So I can write log of 7 to the power of 2x minus 1 equals to log of 150. I now use this law again, and I take that exponent out. And just as for the previous example, I need to make sure that I write this entire exponent in a pair of parentheses when I do. So that would be, if I make myself a bit of space there, 2x minus 1 times log of 7, which will be equal to log of 150, right? Now, I get rid of this log of 7. You could distribute, by the way, if you wanted to. Don't. You'll get there, but it just adds more work. Here, everything's factored for you on the left-hand side, right? So don't distribute this. Just divide both sides by log of 7 right away. Get it out of there. So dividing both sides by log of 7, it turns into 2x minus 1 equals to log of 150 over, let's see, log of 7. Yeah. The job now consists of just isolating x. In other words, you want to make x the subject. For that, first thing I'll do is get rid of this 1. It's being subtracted, so I'm going to add 1 to both sides. And that leads us to 2x equals to log of 150 over log of 7, and with a plus 1 at the end. And finally, I need to divide both sides of this equation by 2, since x is being multiplied by 2. And in doing so, we quickly find that x is equal to, let's see, log of 150 over 2 times log of 7 plus 1 over 2. Okay? All I've done here is divide both of the terms that we had above, the 1 and this fraction, by 2. Okay? If you have trouble seeing how this 2 goes onto the denominator, just remember that all that division is the same thing as multiplication by 1 over 2. Okay, so if I were to multiply this, whoops, not the pen, I meant the highlighter. So if I wanted to multiply this fraction at the top here by 1 over 2, the numerator would get multiplied by 1, and the denominator would get multiplied by 2, which is how I got this. Okay. Now at this stage, let's just plug this in our calculator. Right? You could simplify it further. You could write the whole thing as a single fraction. Honestly, in this, if it's a calculator paper, I really would say play it safe. So let's do that. So I'll go ahead and say, okay, well, let's calculate log base 10 of 150 divided by, in parentheses, 2 times log base 10 of 7. Okay, that's my log base 10 of 7. And I need to add to all of that a half, so I can just say 0.5. And done. And so we see there from the calculator that x has to be equal to 1.78748. And that's the answer. Okay, again, I'm deliberately not rounding here, but if it were rounded to 3 significant figures, this would be 1.79. Okay, good. Now with that first, I want to say example done, I'm going to show you something else. Oops, actually I wanted to add something in between before I work on the sequence. I'm going to give you a few minutes to try and solve some of those for your own. Okay, so let's see. If I were to give you, I'll just give you a couple. Okay, it won't be overwhelming. Don't worry. If I were to give you 2 to the power of 4x, and that's going to equal to 25. Then I want you to solve, and don't worry, I'll get the calculator there. Actually, I can get that out of the way right now. There we go. Then, if I look at question B, I want you to solve 3 to the power of 3x minus 1 equals to 100. And finally, C, I want you to find 2 times 4 to the power of x plus 1 equals to, let's see, 250. Okay, so what I'll give you a couple of minutes. Okay, and when I say a couple of minutes, I mean per question. Okay, so start with this question here. Try solving it the way I just did, and I will correct it in, say, 2 to 3 minutes. Okay? Good, and whilst I do that, I will hide the camera, and that way I don't just sit in front of the camera strangely. Okay? I'll give you 2 minutes for that. Okay, everyone, sorry, just need to get back to the right page. There we go. Okay, so as I just said, I'll correct the first one, then I'm going to give you a couple minutes again to work through the second one, okay? So let's see, I'll just open it up properly there, I can see that better. Now, if I now look at 2 to the power of 4x equals to 25, that's really similar to one of the examples we just worked through, okay? And the approach is identical, right? The number which is being raised to a power is alone on the left-hand side, so there's no real rearranging we have to do initially. So all we have to do to solve this now is quickly just apply logarithms to both sides, all right? So let's see, if I say, okay, log base 10, no need to write the base 10, of 2 to the power of 4x equals to log of 25, okay? Now that that's done, I can use the rule. I won't write it again this time. And I can just take this power of 4x outside of this pair of parentheses, or outside of the logarithm. And in doing so, this whole thing becomes 4x times log of 2, and that's equal to log of 25. Now, remember, I can rearrange the order. There are 3 things that are being multiplied here, 4x and 2, and so I can rearrange this. Remember, multiplication is commutative, right? That's in case you had forgotten the word. I can rewrite this as x times 4 times log of 2, and that's equal to log of 25. Now, all I have to do to make x the subject is divide both sides of this equation by 4 log of 2. Okay? And in doing so, this quickly turns into x equals to log of 25 over 4 times log of 2. Okay? Once that's done, we're home safe, basically. All we have to do is use our calculator. All right, so if I do that, and I'll just quickly open up my larger version of my calculator. There it is. And so I need to calculate control log. Remember, this is base 10. So log base 10 of 25. And I divide that by, in parentheses, to make sure that 4 can be included, 4 times log base 10 again. So again, log base 10. There we go. Of 2. Exit the parentheses and enter. And in this case, x is equal to 1.16096. That's the answer. Okay. Once more, I'm not rounding here, but if you were to write this to 3 significant figures, as is more than often the case at IGCSE, it would be 1.16. Okay. Now, I'm going to give you a bit of time to work through the second one. Okay, say a couple of minutes. So start that. I'm of course going to correct it literally in a couple of minutes. But while you're working, I'm going to answer one of the questions that I just saw. Okay, and sorry, just to be clear here. I'm just checking everything. Okay, good, yeah. I think I've answered everything there in the comments. Just to be clear, for the end of year exam, I wrote it there, but I want to make sure that everyone hears it as well. The answer to the question whether or not logarithms will be present in the end of year exam is yes, absolutely. Okay, and I'll go further than that and say that it's more than likely to be present in both a calculator and non-calculator paper. Okay, the reason for that is because the logarithm unit or chapter is present at IB, and like I told all of you a few weeks ago when we found out that the IGCSE was being cancelled this year. And I think we all agreed, we saw this as an opportunity to go a little further for some topics. So meaning I narrowed down the spectrum of things I'm going to be testing you on. Nonetheless, for some of them, this is one of them, we'll be going a tiny bit further. Don't worry, it's not going to get much harder than what you're seeing now. Okay, and you'll therefore definitely be tested in the end of year exams on logarithms. Okay, so that was a good question. Thank you for that. Okay. Next question while you're still working on it. How will the end of year exam go? Again, this is something I should hopefully know by the end of today or by the end of tomorrow. Hopefully, right? Simply because we have, and I know the person who asked me that question is aware of it, simply because we have a large staff meeting this evening, and I'm hoping to find out more as to whether or not the school will be, officially opening up, and whether or not grade 10 and myself will all be present for the exam. So to answer the question as best I can, if we're in or on the school premises, you'll have two papers, one with calculator, one without. Okay, plain and simple. The exact duration of them, I don't know yet. Okay, but I'm guessing it will be roughly 1 hour 30 minutes for each paper. Okay, if on the other hand, and it's starting to look unlikely that you won't be back at school for the end of year exams, but if we're not, okay, then in that case, it'll have to be something we do with calculator, and it will have to be something live, okay, via Zoom or something like that. What topics are we going to have? I mentioned that is just being asked. I actually answered that question in one of our previous live sessions, and like I said, I'm going to be sending you a full list. Okay? And the last question there, no, you don't have to study all the topics, okay? Not all of the topics. I mentioned a list of things and I don't have my notepad on which I wrote that list next to me right now, but I will type it for you and send it to you, okay? I'll manage back. So no, do not worry, it was not all the topics. Mainly functions, algebra, trigonometry were the key ones there, and probabilities, statistics. That's what I narrowed it down to, okay? Keep in mind, logarithms falls in algebra, okay? So I'm not cheating in any way here when I say that, okay, everyone? Now, I'll go back to correcting this second question. Here we have 3 to the power of 3x minus 1 equals to 100, okay? And the idea, again, we're dealing with the power of some number, and so the first thing we need to do is to get, this unknown which is in the power outside of there. So long as it's a power, or so long as it's written as an exponent, we can't figure out, or at least not easily, what x is, okay? So the first thing I'll do is apply logs to both sides of this equation, and that would be, so log of 3 to the power of 3x minus 1, which equals to log of 100. Remember, this is base 10, everyone. In fact, for this one, I'll remind you of that fact by writing it in green right here. This is log base 10. So with that in mind, I'm sure most of you can tell me what log base 10 of 100 is, right? Or rather, ask yourself, to which power do you have to raise 10 to get 100? And I'm quite certain you can all tell me that that's 2. So I could actually replace this entire right-hand side here by 2. Okay, just keep that in mind. Now, taking this exponent outside of this logarithm, and to do so, remember to write both of those terms, 3x and the minus 1, inside a pair of parentheses. This turns into 3x minus 1 times log base 10 of 3, and that equals to 2. Next, I divide both sides of this equation by log base 10 of 3. I divide both sides by log base 10 of 3, and that leads us to 3x minus 1 equals to 2 over log base 10 of 3. Next, remember, I'm trying to make x a subject here. This is my goal. That's what we're after. So I need to get rid of this 1 which is being subtracted on the left-hand side, and for that I add 1 to both sides. In doing so, this turns into 3x equals to 2 over log base 10 of 3 plus 1. Finally, last step, x is being multiplied by 3. So to get rid of that 3, I divide both sides by 3. Okay? Another way of thinking of that, like I mentioned earlier, I'm going to multiply both sides by 1 over 3. Remember, that's the same thing as division. And I think it's quite useful when working with fractions like this. In doing so, this turns into x equals to 2 over 3 times log base 10 of 3 plus 1 over 3. And that's as far as you'll go, I want to say, by hand. Now, we look at the calculator, and if I go to mine, there it is, I need to calculate 2 divided by, in parentheses, because I have this 3 multiplying the logarithm, so I use parentheses here, And that's 2 divided by 3 times, sorry, I was typing it instead of actually, there we go, control, 3 times log, and did I write it inside parentheses? It doesn't look like I did, so let me just, see, I said it and actually made the mistake, there we go. 2 divided by, in parentheses, 3 times, let's see, log, there it is, log base 10 of 3. I exit the parentheses, plus 1 over 3. Yeah, that's what we're doing. Double checking. Good. And I now enter. The answer, as you can see there, is x equals to 1.7306. And that's the answer. Okay? Now, I'll move this to the side a bit, and I'll move my calculator, and I'm going to ask you to spend a couple of minutes on that last question there. Okay? So I'll give you, say 2.5 minutes, and then I'll correct it. Okay, everyone? So you won't hear me talking unless I see questions in the comments. But I'll be right here. Okay, everyone? 2 minutes. Okay, seeing everyone who's present. Good. Received. Now you're going to see me live helping my daughter get onto Zoom. Okay. Yep, so hang on. There it is. Okay. Yep, that's your Zoom ID number. Okay. Yeah, that's fast. Open up Zoom. Enter. So 924. 924. Yep, 76 96, and I'll let you read the last 4 digits. 470. Okay, cool. All right. Okay. Now let's see. If I move on, and I look at the last one here, so we have to solve 2 times 4 to the power of x plus 1, which equals to 250. Okay. Now, this is slightly different to the previous ones because hopefully you noticed, and if you didn't, don't worry. Now that I say it, it's going to be quite obvious. Here's the idea. In the previous examples, all I left you with on the left-hand side was a number raised to the power, and inside that power, we had the unknown we were after. Okay, so it was just a direct application of, I apply the logarithms, and once I've applied the logarithms, I simply, solve following pretty much the same steps each time. In this case, though, I've got a 2 multiplying the 4 to the power of x plus 1. Okay? And when that happens, I need to start by getting rid of that. Okay? I cannot apply the logarithms right away. Okay? Because otherwise I'm going to be stuck with this 2 inside the log, and if I am, I can't use the law of logarithms. It has to be, let's be clear here, it has to look like this, log base b of a to the power of x. That's what it has to look like for you to be able to take the power outside of the logarithm, right? You can't have a 4, you can't have the 2 here inside there as well. So let's do that. The first thing, I'm going to divide both sides by this 2 that's multiplying the 4 to the power of x plus 1. So dividing both sides by 2 leads to 4 to the power of x plus 1 equals to 250 divided by 2. Well, 250 divided by 2 is 125. Now that that's done, I've basically turned this equation into one similar to the previous. And so I can now apply logarithms. So applying log to both sides, I write log. And you know what, I'll try and keep in the habit of always writing the base 10, that's what we're working with. Log base 10 of 4 to the power of x plus 1 equals to log base 10 of 125. And now I can use the law that we saw to take this power out of there. Remember, there's more than one term in the power, therefore I need to write it inside a pair of parentheses. Right, so I can go ahead and say, all right, that we have x plus 1 times log base 10 of 4, and that's equal to log base 10 of 125. Now that that's done, I need to get rid of this log base 10 of 4 on the left-hand side, and for that, since it's multiplying this pair of parentheses, for that I divide both sides by log base 10 of 4. Okay, so let's go ahead. If I divide both sides by log base 10 of 4, this turns into x plus 1 equals to log base 10 of 125 over log base 10 of 4. Now, remember we're looking for x, we need to get rid of this 1, which is being added on the left-hand side. Since it's being added, to get rid of it, we're going to subtract 1 from both sides. And that leads to x equals to log base 10 of 125 over log base 10 of 4. And a minus 1 at the back here. All right. At this stage, we're good to go. All we need is our calculator. Okay. And we can go ahead and take the logarithm, so that's going to be log base 10 of 125, and I divide that by log, again, base 10 of 4. And from that, I take away 1. Okay? And the answer we're getting here is the one you see. We find x equals to 2.48289. Done. That's the answer. Okay? All right. Now that that's done, I'll move on to the next page. No, I'll add another page. You know what? I want you to work on a couple of those. So what I'll do, I'll leave the sequences till last. And here's what we're going to do. I'm going to ask you to solve 3 times 2 to the power of 4x plus 1 minus 1 equals to 200. Okay? And for that, I'll give you, say, 3, maybe 4 minutes. All right? So go for it. If there are any questions, do ask them. All right? I'll go back to the comments and all the rest. And if not, just power through. I'd say, roughly 3 minutes. Okay? I'll hide the camera for 1 second. I want to make sure everything's okay with my daughter. Sorry, she's doing her live class in the background that you may hear. But anyway, I am here. Okay, everyone, I'll start correcting. And of course, I'm being very silly. Being very silly. You can't see that, of course. Sorry about that. There it is. That's the equation I wanted you to solve. My apologies, everyone. So I'll give you a couple of minutes for this one. Okay, sorry. We'll start the clock again. So I'll give you, 2 to 2.5 minutes for that. Sorry, I hadn't realized I had that equation hidden. Okay, go for it. Okay, everyone. So, sorry about that. Sorry that I initially hid the actual equation. Hopefully that won't happen again. That's not very convenient. Now, the idea is, in this case, again, the approach, if you wish, regardless of how complicated these may initially get, the approach is still the same to start off with, all right? You can see here that it's an exponential equation. The unknown we're trying to find is placed as an exponent on this 2, so our first job really is to isolate this power of 2. Okay? In other words, we want to make sure that 2 to the power of 4x plus 1 is the subject on the left-hand side. Now for that, the first thing I'll do here is get rid of this 1 that's being subtracted on the left-hand side. In turn, to get rid of a 1 that's being subtracted, I add 1 to both sides. So let's do that. This will quickly turn into 3 times 2 to the power of 4x plus 1, and that's equal to 200 plus 1, so 201. Right? Not too bad there. Next thing I need to do, remember the objective, you want to have this power of 2 on its own here. So you need to get rid of this 3 that's multiplying it. For that, I divide both sides by 3. Let's go. This is 2 to the power of 4x plus 1, which equals to 201 over 3. Now at this stage, we're in the right zone, basically. We have nothing but the power of 2 on the left-hand side and a number on the right-hand side. So all we need to do now is apply logs. And again, log base 10, I'll just say, okay, log base 10 of 2 to the power of 4x plus 1 equals to log base 10 of 201 over 3. Now I use the third law of logarithms that we saw, and I take this exponent outside of the logarithm. And because there are 2 terms, remember, one term being added to another, we need to write those 2 terms inside its own pair of parentheses. In other words, this quickly turns into 4x plus 1 times log base 10 of 2, and that's equal to log base 10 of 201 over 3. Yep. Now we need to get rid of this log base 10 of 2 on the left-hand side, and for that we divide both sides by log base 10 of 2. And that looks like this. It turns into 4x plus 1 equals to log base 10 of 201 over 3 over log base 10 of 2, right? Now I'll carry on with the working at the top here. So I'll just indicate that I'm moving to the top of the page like so with a little arrow. And starting from this last part here, I need to get rid of this 1 that's being added on the left-hand side. And for that, I'm going to subtract 1 from both sides of this equation. That leads to 4x equals to log base 10 of 201 over 3. And all of that is written over log base 10 of 2. Finally, we're nearly there. Finally, we need to divide both sides of this equation by the 4 that's multiplying the x. And again, you could think of that as just multiply both sides of the equation by 1 over 4. That turns into x equals to log base 10 of 201 over 3, all of which is written over 4 times log base 10 of 2. And that's the answer. Now again, at this stage, this is not something you would do by hand. Okay, beyond this point, you need your calculator. And so if I take my calculator here, let's see, there it is. I need to calculate, there we go, log base 10 of 201 over 3. And I divide that by, in parentheses, 4 times, let's see, log, sorry, there it is, log base 10 of 2. Exit the parentheses and enter. And in this case, we find that x is equal to 1.51652. Done. That's the answer. Okay? All right. Now, for now, I'm going to step away from exponential equations. Don't worry, we're going to come back to these either in live sessions like this one or as worksheets or something like that I'll be sending you. But I'm going to step away from these for a minute to show you one of the, I want to say very, 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 very common applications of these for geometric sequences. Okay, you may remember those are some of the sequences we saw earlier on in the year. And so if I just move to the next page, we have this. Okay, and essentially this is, I want to say this is something, a classic type of problem you have to know how to answer. Okay, and here's the idea. We're given a sequence. Its terms are 2, 6, 18, 54, 166, and so on. All right. Now these 3 dots, of course, means it goes on forever. Okay, so it's going to follow this pattern forever. Now looking at this sequence of numbers, hopefully you can see that I'm quite clearly not always adding the same amount. And just, after a bit of inspection, I see that, okay, well, to get from 2 to 6, I multiply by 3. To get from 6 to 18, I multiply by 3 again. You can check, but the same can be said from 18 to 54, and so on and so forth, right? So basically, I'm always multiplying by the same amount to get from one term to the next. Now, hopefully you may remember. Hopefully you remember, and if you don't worry. Quick reminder here. When I multiply by the same amount to get from one term to the next of a sequence, it's known as a geometric sequence. Okay, and that's something we saw earlier on, way earlier on, but we did see it. And the first thing we need to do, question A, is find the formula for the nth term of this sequence, right? Now, for the formula for the nth term, you may remember, if I just write this at the top here, and I'll write a little A at the top so to say that I'm answering question A. You may remember that the formula that we're after, we've always called U sub n, right? Where U just refers to or U can refer to any one term, and this n here is the variable, essentially. And the formula that you quite simply need to know off by heart, we had shown it together in class, but the formula you have to know is that the nth term of a geometric sequence is equal to U sub 1 times R raised to the power of n minus 1. Okay, don't worry, I'm about to remind you of all of those of everything inside this formula. But that's the formula that you have got to remember. And in fact, I'll go ahead and box that. That's the nth term of a geometric sequence. Okay, make sure to, if you're making any flashcards for studying or anything, this is one of them. Okay, you need to know this formula. Now let's see what's this actually saying though. Remember this u sub 1, that means when we write it like this, that's just referring to the first term of the sequence. Okay, now looking at the sequence of numbers we have here, hopefully you can see quite clearly, the first term is 2. Right, so u sub 1 in this case would be 2. R is, hopefully you remember, that's known as the common ratio. Okay, and R is equal to the amount by which we have to multiply each term to get to the next. So in this case, I'm sure you'll agree, R is equal to 3. Now, how do we actually find, why is it called common ratio? Why is it called common ratio if what I'm doing is multiplying? Because ratio, I think you'd agree, ratio implies division, right? The ratio of two things. And the fact is, this is known as the common ratio because if I look at any term and I divide it by the previous, 6 divided by 2 is 3. Then if I look at the next one, 18 divided by 6 is also 3. 15 divided by 18 is also 3. Okay, so each time, if I take any one term and divide it by the previous, I get 3. That's why it's called the common ratio. That being said, that was a bit of a sidestep to remind you of a couple of things. That being said, I can therefore state that the nth term, the formula for the nth term is u sub n equals to 2 times 3 to the power of n minus 1. Okay, that's the first answer we're after. In fact, I'll go ahead and box that result. That's the answer to question A. Okay. Now, sorry if you can hear my daughter right next to us. I know she's right in class and answering some questions. Okay. Now, if I look at question B, so I'll just write a B here. We're asked to calculate u sub 10. So in this case, we're being asked to find the 10th term of this sequence of numbers. One way, of course, to do it would be just to keep on multiplying by 3 until you reach the 10th term, and you'll get it. You'll get the right answer, you'll get full marks as well. But for all practical purposes, you don't want to do that, okay? Because you may find that from one year, what if I ask you for the 30th term? You're not going to be calculating this times 3 that many times, okay? You'd be wasting too much time, and it's likely to be a 1-point question, maybe 2, okay? So to calculate u sub 10, the 10th term, you want to really be using the formula you just found, okay? And the idea is to show the examiner, and this will still be true at IB, right? The idea is to show the examiner that you know how to use what you just found, okay? So let's do that. If I go ahead and say, all right, well, u sub 10 equals to, well, what do I actually have to do? Starting from this, I need to replace every n that I see by 10. So u sub 10 will be equal to 2 times 3 raised to the power of 10 minus 1. That quickly leads us to u sub 10, 10th term, is 2 times 3 to the power of 9. Now again, this would be a calculator question, right? You're not going to calculate 3 to the power of 9 by hand. Not that you wouldn't be able to, but it's going to take some time. Okay, so for that, as soon as we reach that stage of our working, we jump on the calculator and quite literally go, okay, 2 times 3 to the power of 9. Right? What's that equal to? Quite a large number. The answer is, it's 39,000, am I seeing that right? Yes, 39,366. Right? That's a pretty large number. If you think of how fast this sequence is growing, we started from 2, and by the 10th term, we're already at this number, that's quite a lot bigger. Okay, and you can imagine if you go to the 30th term, 50th term, it goes, well, it's exponential growth is exactly what this is. Okay, so if I now look at question C, and in this question, we're being asked which term will be the first to be bigger than 5 million. Now, this is important. This is where, I told you logarithms and exponents and all the rest. This is where that actually comes into play. As soon as you're dealing with a geometric sequence, and I could add to the list as well, geometric sequence includes interest rates, by the way, or compound interest. And we're going to be seeing some examples of that probably next class. But as soon as you're dealing with anything like this, you need to have the reflex and be thinking, okay, I can solve this with logarithms. And when I write this out, I think you'll see why. What we're trying to figure out here is when will our sequence, which term of our sequence will be bigger than 5 million? So let's see. The generic term of our sequence is 2 times 3 to the power of n minus 1. So what we're trying to figure out is for which value of n is 2 times 3 to the power of n minus 1 bigger than 5 million. Okay? That's what we're actually trying to figure out here. And to be clear, when we find n corresponds or tells us which term we're dealing with, right? So, for instance, here for the 10th term, n was 10. I replaced n by 10. So if I can use this inequality, I can solve this whole thing and figure out what n has to be bigger than for the left-hand side to be bigger than 5 million, right? So that's what this entire problem turns into an inequality in which we can solve using logarithms. So let's look at this. First thing I'm going to do, just like we did in the previous equations we worked through, first thing I'm going to do is divide both sides of this equation by 2. The objective being I want to isolate this 3 to the power of n minus 1. Okay? That's the first thing we'll do. So we'll say 3 raised to the power of n minus 1 has to be greater than 5 million divided by 2. Okay? 5 million is an even number. Don't go writing that as a fraction. That's just going to be 2,500,000. Right? And now, hopefully you can appreciate that this is now looking extremely similar to the equations we were working with. Now, it's not an equation, it's an inequality, but it's extremely similar to if I gave you this. 3 to the power of x minus 1 equals to 2,500,000. Right? And we've just worked through around 6 of these. No problem with those. We're going to solve this in a very, very, very similar way. First thing we do is apply logarithms to both sides of this inequality. So let's go ahead. We can go ahead and state that, all right, well, log of, and that's, I'll say, log base 10 of 3 to the power of n minus 1 is greater than log base 10 of 2,500,000, right? I now use the third law of logarithms again, and I take this power of n minus 1 outside of this logarithm, right? And in doing so, this turns into n minus 1 times log base 10 of 3, and that's got to be greater than log base 10 of 2,500,000, right? Now, you may recall that when we're solving inequalities, the only thing you've got to be you basically solve them the same way as you solve any equation. Okay, the method is identical. The one thing you have to keep in mind, though, is that when working with inequalities, if ever you multiply or divide both sides by something negative, okay, then you need to reverse the inequality symbol. Now I'm going to break the suspense. That won't apply here. Okay, I wouldn't have started with an example like that. For this one, log base 10 of 3, you can check with your calculators, that's not going to be negative, so we're going to be fine. Okay. I divide both sides of this inequality by log base 10 of 3, and that leads us to n minus 1 has to be greater than log base 10 of 2,500,000 over log base 10 of 3. Finally, I need to get rid of this 1 that's being subtracted on the left-hand side, and for that I add 1 to both sides. So that turns into n has to be greater than log base 10 of 2,500,000 over log base 10, sorry, should have enough space there, yeah, log base 10 of 3 plus 1. And we're pretty much done. All we have to do now is figure out what this right-hand side is actually equal to, and that will tell us what n has to be bigger than. Okay, so if I go ahead and do that, I'll actually plug this entire right-hand side inside my calculator, and in doing so, let's see what we get. So I type in log, that's log base 10 of, in parentheses, 2,500,000, 1, 2, 3, there we go. It's 2,500,000, and I divide that by log base 10 of 3, so let's see, log base 10 of 3, and I add 1 at the end there, right? Done. And the number we get, I'll write this in a different color, the number we get on the right-hand side, this entire right-hand side, that is equal to 14.4095. And here's the trick. Remember what n actually is. N tells us which term we're dealing with. First term, second term, third term, etc. N is a whole number. In fact, it's a positive whole number. So we're looking for the first positive whole number, which is bigger than 14.4095. I'm sure you have no trouble seeing that the first number n has to be greater than is 15. And so n has to be greater, n has to be greater than or equal to 15. And therefore the first term would be u sub 15, the 15th term. Okay? Now, looking at the time, typically you have 7 minutes left. What I'm going to do is leave you with this, but I'm going to give you, or actually I'm going to ask you to repeat this same question. Literally, I want you to repeat it, but I'm going to give you a different sequence of numbers. And the sequence of numbers I'm going to give you, I'll write in, let's see, I'll make it a bright color so it's very obvious what I've changed. So I'm taking this sequence of numbers, which I wrote earlier on. So exactly the same questions, 4, 16, 64, oops, sorry, didn't mean to write 164, there you go, 16, 64, 100, no, sorry, I'm doing the wrong one, 256, 1024. Okay, that should be it. Let me double check. Yeah, 4, 16, 64, 256, yeah, we're fine, okay? Same questions with that pink sequence of numbers, okay? And in fact, let me just check. Let's change this 5 million to 10 million. Okay, so questions A and B are identical. Question C, same question really, but I'm replacing 5 million by 10 million. And the sequence of numbers is the pink sequence of numbers you see at the top here. Okay, so for next class, I want you to work through those same questions and solve them, all right? And I think we'll start next class just by working through this example. Following that, we're going to look at a few more applications of, logarithms, and you'll see that they're very much linked to geometric sequences and exponential growth. Okay, everyone? So I'll leave you with that. Really hope, this is working, that was helpful. And there we go. Okay, everyone. Take care.